All right, today we're talking about DNS. Now, DNS stands for Domain Name System. Let's learn about what that means and what this all entails. All right, so in a previous class, we learned that computers are able to find one another all the way across the internet because every device has its own distinct IP address. So every computer can find any other computer if they know what their IP address is. In last class, we learned about how browsers send requests to servers in order to get whatever resource we want to see. So if we want to see the homepage.html file from example.com, we need to send a request to the example.com server. We type a URL into our web browser, and then our browser sends that request to the server with the appropriate domain. And servers are just like any other device on the internet. They are most easily located using their IP address. They have one just like any other device. Now, it is a huge hassle for us as people who are using the internet to try and remember all of the IP addresses for every website we want to try and visit. So somehow we need to map our names of our websites, example.com. We need to map that to the IP address for that server for the domain. And that is where the domain name system, or DNS, comes in. DNS is going to translate the names of domains into their corresponding IP addresses. So, like we just talked about, every website has its own unique domain. We talked about this last class, where every single website has its own specific identifier, their own very specific name, so that we can find them on the internet. If I type in google.com, I'm not going to find wikipedia.org. They have their own distinct names. And along with those domains, every domain has their own IP address. So if I typed 172.217.18.174 into my web browser, I would get to google.com. That links me directly to the server for that IP address. That'll get me right to Google. And DNS is like an address book. In our phones, we don't have to remember everyone's name and phone number. All we need to know is who do I want to call? What is their name? And our phone remembers for us what phone number is tied to it. DNS is just like that. It's going to remember the IP addresses for all of these websites. So all that we have to remember is that name, google.com, CodeHS.com. So I don't need to remember this sequence of numbers because that's way more effort than remembering CodeHS.com. So, like we mentioned earlier, every server has their own IP address where we need to send our requests if we are going to be getting any resources. So, we need to translate our name to an IP address with DNS. So when you type that URL into your browser, this system, the domain name system, is going to tell you what the IP address for that URL's domain is so that your request can be sent. And it's going to, very first thing it's going to check is, do we already know this IP address? So if our computer has recently visited a site, or if we visit it frequently, our computer is probably going to remember the IP address. And the system that is in charge of remembering things is not actually called memory, it's called the cache. So our computer is first going to check its cache to see if it already knows the IP address for this website. So let's say this is our cache. We have google.com, this IP address, with CodeHS.com, with this IP address, with wikipedia.org, with this IP address. Clearly, example.com is not there, so we're going to have to actually use the DNS. And this process is going to move from the end of our domain forward to the beginning. So we're going to start at the right and we're going to move leftward. So our first step, or I guess not first step, our second step is asking a root server. So we're going to look for the com domain. So first step is asking this root server. And DNS is a hierarchical structure. So the very top level is the root. There are root servers basically all over the world, and their only job is to remember where these top level domain servers are. So where is the com server? Where's the gov server? Where's the edu server? So any website with a com address, or the com at the end, its information is going to be held within this server. And it does not need to know anything about any website that ends with an edu or ends with a .org. So we're already splitting up the roles a little bit. So we're going to ask the root, hey, where is that com server? Where can I go to find information about .com domains? So we send that request to root. It says searching, searching, searching. It's trying to find it. Oh, okay. You're going to check this IP address. Go here. So this IP address is the address for a com name server. All right, so we have that IP address. Cool, thanks. All right. So next we're going to ask a TLD server for a more specific thing. We can ask com where example.com is now. So if we go to the next level down in our hierarchy, we went from root to top level domain. So we're following this path to our com server. And then on the com server, any website that ends in .com is going to be known about here. So we can find CodeHS.com or example.com. Different servers might have different websites, like Wikipedia is on the org server, VCHS is on the net server, things like that. So within the com server, we're going to try and find where example.com is. So our computer is going to ask, hey, com, where is information about example.com? It says, all right, let me find it. All right, I'm going to send you another IP address. Go check here. All right, cool. Thank you. So we're going to the next level down. We're asking a hosting server for example.com. So as we are moving down into our through our hierarchy, we've gone past our second level domain into a subdomain now. So within each of our second level domains, so within example.com, we could have www.example.com. We can have about.example.com. With VCS.net, we can have www.vcs.net or learn.vcs.net. Those are both subdomains within our VCS second level domain. So we are now going to ask our example server, hey, where is www.example.com? We're moving further and further down our hierarchy, getting more and more specific. Example.com says, oh yeah, I know where www is. You can find that at this exact IP address. Say, cool, thank you. Now that we have that address, we're going to save it into our cache in case we want to visit example.com or www.example.com again soon. We want to find it very quickly rather than having to ask all of these servers again. If we have it in our cache, it's almost instantaneous to find that IP address. Otherwise, we're going to have to ask every server again, can you tell me where com is? Can you tell me where example is? Can you tell me where www is? And while that is a fast process, the internet is, once again, very, very quick. It's even faster if we don't have to go through that whole thing. So we're going to save that information into our cache. And then we are actually going to send our request, like we talked about last time, how we are going to send requests to our server. So example.com, that's our address. We're going to send that request saying, hey, server, please send me your homepage.html file. It says, you got it, boss. Here it is. Boom. We've sent a request. It sends the response. And then we render that HTML. And we can see the beautiful web page that we get in return. So this hierarchical system makes our DNS system, the domain name system, I guess system, I'd say DNS system, it's very scalable. And since each layer is only in charge of a small amount of information, root doesn't need to know about.example.com specifically. Root only cares about COM addresses. It only cares about the server for COM addresses and gov addresses. It only cares about this next layer. And then each of these only cares about the next layer down. And then each of those only cares about the next layer down. So it's really, really easy to add a single element to a layer, as well as add another layer down below if we needed to. In addition to that, it's way, 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 way faster to search through one layer for root to find all of these different values rather than searching through every single possible domain ever. So if I want to find about.example.com, it's much faster to go down through each level rather than looking through every domain across the entire internet to find that very specific one. If we can narrow our searches, it's going to make finding happen a lot more quickly. So the biggest takeaway from this lesson is that DNS is going to allow the internet to map the names of domains, which are easy for us humans to remember, to those IP addresses, which are very useful in actually locating things on the internet. So we're mapping useful to humans to useful to machines so that we can efficiently use the internet. All right, does that whole system make sense, that whole process? Any questions on that? Cool. Okay.